So here's an example involving indicators. So remember, indicators are just weak acid base conjugate pairs. If you look in your data books on page 12, you'll see, or sorry, page 10, there's the list of indicators. So the conjugate pair, the only difference, right, is a single hydrogen. This is not actually the chemical formula for these indicators. It's just a shorthand way of writing it because some of them have quite complex chemical formulas. But because they are a conjugate pair, we just show the difference being a single hydrogen between the two. And the question is asking, predict the reaction if drops of bromothymol blue are added to a 0.1 mole per liter solution of hydrofluoric acid. So the first thing that we need to do if we're predicting a reaction is to write out all of our species that we have present. So bromothymol blue is HBB and then the bromothymol ion. So this is our conjugate pair. Sorry. Okay, it's a solution, so we also have H2O, and then hydrofluoric acid, HF. This is a weak acid, so we're not going to show the ions, we'll just leave it as is. So now we have to predict what is going to be the reaction. So we have an acid, water is an acid, and hydrofluoric is an acid, and then bromothymol blue and water is a base. So if we go to page 10 and look up bromothymol blue, it has a Ka value of 5.0 times 10 to the minus 8. So even though it's not shown on the same page as this acid-base chart, the Ka value will tell us where it belongs. And the only reason that they haven't combined those two tables is just because it would be such a massive table in your data book to work with. So here's the Ka for bromothymol blue, 5.0 times 10 to the minus 8. So we're going to use that to fit it in here. And it's going to go in between these two numbers. So 6.2 times 10 to the minus 8 and 4.0 times 10 to the minus 8. So this is where our bromothymol blue is going to fit. So just imagine that you added like an extra line on your chart and you have your bromothymol blue acid and conjugate base right between these two. Now if we predict our acid-base reaction, starting from bottom up, we get our strong base. Okay, and then if we start from the top down, we get our strong acid will be HF. So the hydrofluoric acid will be the strong acid. Now if we write out our net reaction, we have HF, aqueous, plus the bromothymol blue ion, and they'll react to produce, so we'll transfer an H plus from the acid to base. So we're going to be left with fluoride ions and bromothymol blue acid. So we have our conjugate pair here and a conjugate pair here. If the question asks you to identify the color of solution, the hydrofluoric acid is colorless and the fluoride ion is colorless. So that's not going to impact the color of the solution. But that's what's unique about all of these acid-base pairs on page 10 is that they do have a color. Okay, and depending if it's the acid or base, it's going to be different in color. So for example, methyl violet, the acid form of this is yellow. The conjugate base has a blue color. So if we go back to this bromothymol blue, HBB, so the acid, has a yellow color, and the conjugate pair, the ion, has a blue color. So this guy is blue, and this one is yellow. So what's the color of the solution going to be when this reaction takes place? So I'm producing the conjugate acid as my product, which has a yellow color. So the resulting solution here would be yellow.